Welcome to Dave's American Flyer Trains. Join me to explore American Flyer trains by A.C. Gilbert, rebuilt and maintained to engineering practices, factory specifications, standards, and underpinned by lessons learned from literature, experience, collaboration, and applied knowledge to update and advance the skill of this craft. Please subscribe. Together we'll preserve these great trains through value-added quality content. Remember, the trains are the show. From 1953 through 1957, the diecast 464 Hudson 326 was cataloged with this number. The locomotive had a smoke and choo-choo unit as well as an operating headlight installed in the boiler. The tender rode on simulated six-wheel trucks with die-cast side frames, and a knuckle coupler was mounted at the rear. In addition to the small logo oval, New York Central System, the tenders were lettered American Flyer lines in white. This is a Type 2, manufactured 1954 through 1957, with a large motor using plastic-covered wires to direct connect locomotive and tender. Hello, welcome to today's American Flyer Trains for the rebuild, highlights from the rebuild, a track stand test and railhead test eventually, and additional videos for number 326, which was made from 1953 to 1957 by the A.C. Gilbert Company American Flyer Lines. This is a 464 die-cast Hudson, smoke and choo-choo, as you can see, is boiler mounted in the four-position reverse unit, and the air chime whistle are mounted in the tender. The road name for this train was labeled on the tender as American Flyer Lines with a New York Central Herald, had simulated six-wheel trucks on the tender, and according to Doyle, he classified it as a Type 2, I think based mainly because of the large motor that you see here, the 3/4 inch field and the large armature. It does have the plastic-coated wiring, direct wiring that goes from tender to boiler. You will not see a jack panel nor a pin panel. That is because it's the way it was built from the factory. And Doyle classified the date range of this Type 2 as being from 1954 to 1957. I subjected this train to my standard rebuild, which was disassembly, washing, alcohol wipe downs, rotary tool polishing, more alcohol wipe downs, reassembly, and final lubrication. And it had some surprises, and I'll highlight those shortly. The tender had four items that I think were worthy of beyond just the standard cleaning and adjusting handrails and things like that. Four items that I think are worthy of mention. One is that it had a missing slide contact that the owner asked me to correct. It was missing the slide contact and the spring. The other one was intact, but it was completely disassembled and polished. Now I also reattached the shoe boxes. Now I do that by applying a clamp to the shoe boxes to clamp the shoe box to the side frame, and then I run a small bead down each side of the shoe using crazy glue. That gets me started. I let that set and cure for 24 hours. Then I come back with JB Weld, remove the clip of course, and then come back with JB Weld, and I build for myself out of a toothpick excuse me, a really small trowel to use to go down the side with the JB Weld, and then finally after the JB Weld sets and cures for at least 24 hours, I come back with the black magic marker and touch that up a little bit. The other thing found noteworthy in the disassembly was the axle bushings for the tender are definitely oblong. There is some vertical wear on these. It is not as extensive as you will see in an eventual video that I'm doing on my 322, but I think it's noteworthy and probably should be corrected at some point in the future with eyelets. The reverse unit was a complete disassembly, and we'll take a look at it. Both fingerboards were removed, top and bottom, as well as the drum. Everything I could reach on the interior and the exterior were polished and cleaned, holding it in my hand to maintain the integrity of its relationship and connection to the speaker and to the capacitor, which is almost out of the camera view. But I did find that one finger it was definitely over 2/3 of the way worn off on the fingertip. So that's the reason for the new board. I also retensioned all the fingers and made sure that each end of the finger had the right relationship and cupping formation and position. And of course, I thoroughly cleaned and polished the drum, and it was all lubricated with CRC 226. So it seems to be performing admirably. And finally, to wrap up the tender, I cleaned, polished, repositioned, and retensioned all of these swipe contact springs. None had holes worn in them, none have any anomalies, but they were very loose against the axle. As a matter of fact, I don't know how one of these in particular was even touching the axle, but I made sure it has solid contact. On those, I generally find that the axle has a very bad black wearing or black deposit of carbon dust and carbon burn on the axle. One of these had that. As a matter of fact, some of the stain even remains. But once these were retensioned and repositioned against the wheels, against the axle, I think it will perform very well. And that brings me to the first point, which took an appreciable amount of time beyond the standard cleaning and the removal of the carbon dust for this train. It definitely was not over lubricated. I've had some that were literally dripping wet that you felt like you could just wring them a little bit and the oil and grease would just drip out of them, including on the axles and where they touch the wheels. Not so on this one. Carbon dust definitely dominated the cleaning routine. But what I did find was that on every driver wheel, of course, except the center one, but the ones with rims, all were touching the chassis. Now I put this train on my layout and operated it just briefly to move it forward and move it backwards just a little bit to see if it was even reacting before I got started on the rebuild, and it was. How it failed to short out, I don't know. I think it could have shorted out should I sent it through a curve, because every rim was touching the chassis. As a matter of fact, there was a circle or ring on the chassis for almost every wheel all the way around where the rim had been rubbing. How this train even ran is beyond me. Now let's take a look at the root cause of that. I've mentioned this before, but this is what I found. And I'm going to over-exaggerate it just a little bit using this wheel. What I found was it wasn't because of being over-lubricated. I'm not quite sure why it was even like this, because the wheels all seem to be very dry, as well as the plastic insulator. But what I found was that each driver wheels was extending outside of beyond the rim, or beyond the plastic insulator, and as a result, this disc right here, that is a raised disc on the back of each wheel, was moving too far in that direction toward the outside, and therefore, as you can see in this profile, I'm going to hold up my hand, you can't see that ring. You should be able to see that ring on the left-hand side of that wheel. You can't do it. You can see the wheel is protruding through the right-hand side. So what I did was I had to remove every wheel individually to maintain the quartering, clean, inspect it. I did not punch the wheel out of the white insulator because they all seem to be tight. It's just that they were in the wrong position. So let me show you how I got them back in the right position. From Port Lines a couple of years ago, I purchased a steam wheel compression tool, and it's been a lifesaver. Now you can take these steam wheels and probably put them in a vise, a metal vise, a rather large one if you have to see if you can get the wheel, the plastic insulator, and the rim to have the right relationship such that this disc protrudes on this side. That disc should be the only thing touching the chassis, because if it is, you can see it's insulated, of course, based on the fact that you got the insulator plastic. If it falls through and starts protruding toward the outside, then you can see that the white plastic starts approaching the chassis as well as the rim, and that just sets it up for shorting out. But this tool allows you to get the right relationship back together. Get the wheel with the right relationship back together. Yes, you can put them in a vise and squeeze them. The problem is, on a vise, you're not going to have anywhere a jig of any type in which this disc can recess so that you can get this back to the right relationship. But not so with this. This allows that. As you can see, it has a depression in the center, which is there to allow the disc to fall into it. So you place this being the wheel, the white insulator, and the rim into this tool, put it on top, and then you put this in the vice grip and squeeze down, And of course, it won't squeeze any further than it needs to. It sets up the exact right relationship with those 3 wheel components. So that was a lifesaver. Now the labor, of course, was pulling each wheel off, which I extracted with a wheel puller. The wheel puller I choose to use, I believe I also got from Portland's, is this one. It works extremely well. It makes this a very, very easy task to pull these steam drivers off. And of course, it's much easier if the chassis is completely disassembled and you got free access to it. Simply slide the lift blades under the wheels. The opposing force is applied by the pin, which you see in front of my finger, and then they just come off. As a matter of fact, generally I can turn this with my hand, and because it's opposing forces, it lifts the wheel right off. After cleaning and using the compression tool, pulling them off with a wheel puller, using the compression tool, I put them back on and make sure that quartering is appropriate. I test the quartering by hand by rolling the chassis up and down the rail head across switches and curves. That's one test. It's not the ultimate test. I also put a side rod on to make sure the right relationship between both sets of wheels. And then I turn it over onto its back and I apply a rotary tool to one of the wheels and get it at really high RPMs to make sure that that side rod does not bend and is in the right relationship. Now, did I ever bent one of these? You bet I have. I got some on one of my very, very earliest trains, I think like in 2015 or 2016 when I first started this, probably in 2015, in which I locked one of these up because I did not have the right quartering relationship. But I found that I usually can quarter these by hand. I'm not recommending you do that because a quartering tool is the right way to go. But if these center wheels are not removed, they have the right quartering relationship, and then you can simply extend that to those 2 wheels. Is what I do simply by using some straight edges to make sure. Now, the very last thing is once I push the wheels back on in the vice grip is I put a tiny drop of crazy glue right there where the end of the axle is. You can't even see it, just to make sure these things are not, you can still break that bond with a wheel removal tool, but just under normal operations, I don't think there's enough pressure to do that. All of my trains are built like that, and I've never had any issues with it. Now that takes me to some of the more interesting issues with this particular rebuild. Once I got it rebuilt, once it was assembled but not thoroughly lubricated, because I wait until I have got assurances that during the testing it's okay before I put the lubrication in at all critical lubrication points, I operate it. This one would not move. The armature simply would not turn over. I did a voltage test at the brush caps right here. It was receiving full voltage when the transformer was turned up. There was 18 volts here. I strengthened the solder point here, and I strengthened one of the solder points up on the field, but I don't think that was it because the soldering points were there. I just didn't trust them long range to be in good condition, so I went ahead and strengthened them a little bit. But I could not get any voltage to go, at least I thought, beyond this point right here. Now, I've experienced a phenomenon before I want to share with you. I have before, on taking apart steam locomotives, experienced where the springs for the brushes inside the brush bracket assembly had 2 per brush, 2 springs. They weren't unique, they were just the standard springs. They were not installed end to end to get additional strength. They were installed wound together like this, which means that when you picked them up, you could hardly tell there was 2 springs there. But if you gave them close examination and then you started twisting them in opposing directions, they would come apart. So the motor wouldn't work, and that was the only change I made because I put the springs back in here as single springs, not double springs. So if you would, imagine these as being doubled up. Now I've seen that before in some steam locomotives and didn't pay a bit of attention to it, but I assure you I will now, and I'm going to go back and revisit at least my Northern 336 because I believe that's one of the trains I identified it with because it has the large motor. So I immediately took the springs out and retwisted them together to make one single spring like this, which of course increases the tension and the pressure from the string. Now I recruited somebody to help me research this to find out if this was a standard at the factory. At no place could we find this. I started with Deeger, Doyle, and Hannon. None of them mentioned this. I did not test Mr. Barker. I didn't look in his book, but I should have, about these double springs, and I think I will once the video's made. Could not find any reference. Now, my associate in American Flyers looked at several things. He looked at the factory service specifications. He looked at some of the orders that go down in work orders and tasks that go down to the service stations as to whether or not that was a fix for that. Couldn't find any reference to it whatsoever. Now, the first time I encountered this phenomenon, I thought it was an assembly just mistake, because these springs, I imagined, were just tossed into a bin, and then the assembly line workers just had to go in there and grab one and put it in and try to work as rapidly as it could. By the way, that's two wrapped together, and it's really hard to tell if there's one in there. And that occasionally they'd get them stuck together, they wouldn't even know it if they picked it up, and they'd just go ahead and throw it in. At least I think that's two. Yep, that's two. Fool me. So I just accounted for that to be an assembly line mistake. However, my friend researched this even further in general as far as brush motors are concerned. And here's what we found. And it is in fact why I like following the science of this as well as just the labor and tasks that are required to rebuild these trains. Is to try to determine why certain things were done in the way that they were done. This author had an article about brush electric motors, which most of them are, in general, about brush wear and tension. And the reason that I was concerned about it, I was getting no action with the train. I put the brushes back in double like this, and suddenly this thing started working very admirably. That's the reason I'm going to go back and revisit my 336 Northern. I didn't put the double springs back in. And this is what he said about what causes a drop in performance of an electric motor over time and excessive brush wear. He had three reasons. Number one was low spring pressure. Well, if you double up one of these springs like this, you're going to get additional pressure. He said it was inadequate spring pressure can cause electrical brush wear. And that included any type of spring, including these what he called watch type springs, like this. They lose force when the brush wears down, and just over time, metal springs lose tension. It's just a property of the metal, I guess. He said that reduces the effective force of the brush to the facing, which in this case is the commutator, and actually continues to contribute to the brush wear, and that is it's not fitting tightly enough against the surface, or in this case with the train's commutator. Number two, he mentioned that it could be caused by poor commutator or ring condition, that is the facing of the commutator and its ability to have a planar relationship with all the plates that are in it. He mentioned that if that plate or the commutator was rough or out of round or otherwise was in general a poor contact surface, it could accelerate the brush wear, and therefore the brush shortens, the tension on the spring reduces, you get less performance, and you get actually more wear on the brush because it's not being have the proper tension up against the commutator. So it can lead to both electrical and mechanical wear. So the recommendation, of course, is to keep those commutator surfaces on any electrical motor clean and flat in a non-out of round condition in which every plate on the commutator has a planar relationship. And I had mentioned this before, in that if that is maintained, then it will, if it's not maintained, it will lead to a shortening of the spring life and inadequate spring pressure. Now, I've seen articles written and performances about how to polish or grind the commutators, and I know Hannon specifically mentions in his book that you need to have a planar relationship between those two plates. And here's what I mean, just to make sure we're clear on this. Let's pretend like these are two plates, on the commutator, and there's the slot where my hands meet. Imagine that being probably a good planar relationship. This one is not, nor is that, in the same relationship with this. This is not, and certainly that's not, nor that. If Hannon recommends that if you grind these commutators and get them out of that planar relationship, you're going to shorten the life of the brush. Therefore, it shortens the spring tension, and it may lead to a reduction in performance. Now, I've seen those who take sandpaper, put them on a 2x4 piece of wood, drill a hole in the wood. They extend the this end of the excuse me, I'm just having a moment here. This end of the armature into that hole. They put the worm drive into a drill, and then they grind away on that really rigid wood surface. And of course, Hannon warns about damaging the points in which the wires are soldered to that plate. I believe that yes, they probably do need to be ground a little bit. It's not a bad idea, but I think the ideal way to do it is with a drill press that has a jig on it that maintains the proper 90-degree relationship with variable pressure, and of course a real fine grit of whatever you're using to polish that with. What I've chosen to do is to use the really fine grit sandpaper sponges. Punch a hole in the sponge, put this end of the armature into that hole, put the worm gear into a variable speed drill that has very low RPM, and push that gently against the sponge, because the sponge will collapse, and it should maintain the same pressure just in the physics approach, because it's collapsing on all the planes of the commutator. So that was item number 2. The third item that the author highlighted is that if any brush holder, such as this one, the brush bracket assembly, is improperly mounted and has not equal pressure on the 2 screws that holds it on, that can include and generate a variety of brush wear. And of course, if they're installed incorrectly and they potentially therefore can cause damage to the surface and wear out the carbon brush even faster. I have found these before in which they were not properly installed, in which this housing right here that holds the brush was touching the commutator. Of all things, it was just grinding a trough into it. And I think that's what this author is talking about. So this author, taking a scientific approach, says low spring pressure can damage, that can reduce the performance. It can even damage the brush even further. Once the brushes are damaged, you don't have the proper spring tension, or you don't have a commutator that has a planar relationship, or you have the brush bracket assembly improperly mounted. All that can lead to it. Well, that being the story, what I did is I doubled up on these springs. I put them back in. Of course, it applies more pressure, not because you did it like this, but because they're wound like this, applies greater pressure, and I turned the motor back on, and boom, away it went. So let's just demonstrate a short track stand test. This is prior to lubrication as well. Keep that in mind. Except on this gear right here, which comes in contact with the worm gear. Thanks to everyone who watched this video to the end. Please subscribe to the channel to see more of this content. Give a like or comment as you see fit. And above all, remember, the trains are the show.